everybody.
It's me, Mr. C. I'm gonna try something a little different today, and we're gonna do a little experiment. It was my daughter and my wife's birthday just recently, and so we had a bunch of these floating around. Oh, it's kind of invisible. There it is. Helium balloons. So they got a little bit spoiled. We bought some, and then my parents bought some, and then their other grandparents bought. So there were lots of helium balloons. Now the fun part about helium, of course, is that it's lighter than air. I don't know if you've ever seen the movie Up, where the guy inflates so many hot air balloons, but when you've got a lot of hot air balloons floating around your house, you gotta wonder, what would it take to actually get a balloon to float a house? What is the buoyancy, what is the buoyancy pressure involved in a hot air balloon? Now, just by chance, I happened to be going through my desk, and I ended up with a Newton scale meter here, one of these, so you can measure it in grams or in newtons. And I was wondering, could I measure that? Now, the only problem is, of course, this measures it in newtons or in grams. Now, that's a fairly small amount, as even just that much pressure. That's like 100 grams or a whole newton. So, is this enough pressure? Well, we're gonna try it today. I am gonna give all the balloons back when I'm done, assuming they survive. Assuming I survive. Here's one balloon. Let's see. I'm gonna get my Newton spring scale here, and yeah, that not only is it's kind of negative pressure, so I can't actually. We're gonna have to scale this up some. Okay, so I've gone around the house and I've collected every single balloon. We're having balloon overload here. Let me just hold on. Okay, so the automatic background removal thing was a bit of a problem, so I had to clean up a little. So here's the spring scale. I don't know if you've ever seen these before, and they work. You pull down, and the spring does the counterpoint, and that the amount of pressure that pulls down is the amount of either grams on one side or newtons on the other. 1 newton is about the amount of pressure it is to hold an apple, average-sized apple, in your hand, just in case you want to perpetuate that myth about apples hitting Newton in the head and all of that. Anyway, so that's a spring scale. I only have this one here, which goes up to 20. There are more delicate or sensitive spring scales, so hopefully what I have here will work. So let's get that balloon. Actually, I need more than one, so I'm just gonna grab everyone in the house. Yeah, that was quick. Whew. Happy birthday. Yikes. This is what you do. You spoil your kid when you're all stuck at home. So, hope you're having a good day. Now there's a couple issues here. Number one, I'm gonna have to figure out how much volume in terms of helium. Wow. This is. The other thing is I have to, of course, have a common measure point. So now, I'm going to attach this anchor point to this spring scale and see what happens. Hey! Look, Ma, no hands. That's fun. Alright, so that's also very low ceiling now. We're gonna see if I can measure the amount of force that this is exerting upward. Alright, I just need to adjust my spring scale a little. And I happen to have pliers. Until it reaches 0, I suppose? You probably can't see that, but it is getting very close. That's really close. Just a slight, little bit more. There we go. Pretty good. You would not be wrong to wonder what this has to do with math. Isn't this science? But it is actually proportional reasoning. Basically, it boils down to, I wonder how many balloons or what volume of helium I would need in order to float myself or a house. That is now zeroed out. Let's give this a try. Okay. Now I have to pull down on this ever so slightly in order to get it to come off the ceiling. Actually, the problem is, of course, I don't, right? It's, well, maybe. Hold on. The mass of it, I'm not touching it right now. The mass of it alone is hovering, just hovering. In fact, I could probably, I could cut these, but I don't want to ruin the balloons for my kids. Anyway, so I'll just hold that up, and then I'll gently tug. So it's 0 grams. The gentle tug. It's so hard to read it. But I think it's about 1 gram? Maybe 2? That can't be right, can it? Alright, so hold on. So, if I hold this just in my hand, it's reading 0. If I put it on here, and then release the balloons, and just hold this at its current height, then I should see a slight change. Let's see. Oh, it is so slight. Like half a gram left. I'm gonna need a more sensitive spring scale. That one's significantly less sensitive. I don't have enough. All right, well, I know it moved at least one itty bitty little bit. So that is about half a Newton, not even. Really, it's one of those, which is, and this is a lot of little gradations. Gotta get better glasses. So this is 200 divided by 5. Okay, so each one of these is about 40 grams. And it moved part of 1. So I'm going to say 20 grams? 20 grams worth of uplift on this little cluster of balloons. So at least that gives us some approximation. So let's say 20 grams worth of lift. Okay, so this many helium balloons is giving me approximately 20 grams worth of lift. Now that's an approximation, but it's the best I can do with the instruments that I currently have. But the problem is, this is not one balloon. This is not one amount of helium. Okay, we're gonna need to count this. $13, $14. Is that right? That can't be right. It has enough pull to actually float this. I suppose the other way to do this would be if I had a certain known mass and I could see if it floats that exact mass, then it would be perfect. So these strings plus this carabiner plus this thing, this spring scale seems to float pretty consistently. It would have to be exactly buoyant, like not positive buoyancy, not negative buoyancy, but perfectly neutral buoyancy. Okay, well. 11, 12, 13, 14. Okay, we got 14 balloons here. Now, some of them are bigger and some of them are smaller. So the smallest ones are the regular, this size. And then the biggest is this big guy right there. Check that one out. That one's cool. I might be able to do this whole experiment just with that one. Maybe I will. And then there's always the weird shaped ones like the stars. I think on average they're probably about this size. So since that's roughly circular and we've been figuring out the volume of a cylinder, we can approximate the size here. So let me grab my measuring tape. This is how I pass my lunchtime. So I'm gonna get my measuring tape. Oh, this is inches. We don't want inches. Well, there's gonna be some converting. So you're gonna have to convert these from inches to centimeters. Thank you. And then we need the height of our cylinder, and we're gonna we're going to assume a slight... We're going to make a bunch of assumptions here. But basically, we're going to assume that it is, although it is rounded, we're going to take out the round in our mind. 7 at the widest point. All right, so let's call that 6. Because some of it will be slightly wider in the center, some of it will be slightly narrower at the edges. Let's call it 12 inches diameter and 6 inches height. You want to think of it like height? And you can calculate the volume, approximately, of said balloon. Now, as I mentioned earlier, another way I can figure out how much force this is exerting is I can figure out exactly how much of something they can lift all together. So if I can actually manage that, I'll probably have a better, more accurate understanding of the amount of mass that these things can lift they can generate. So I'm going to try that. Positive buoyancy? Check. And the mass of themselves, technically, because the balloons themselves will have some, like the actual Mylar balloon. By the way, this is probably not the most environmentally friendly approach to things, but, you know, I'm wondering what I have that might have some mass here. I mean, I've got some measuring tapes. Heavy. Let's try that. I think this will probably be a little too heavy. Oh, yeah. I like the fact that I can do all of this without actually leaving my desk. Just random math and science with the garbage in my desk. Okay, so I'm gonna just wire this in and move my toes out of the way, just in case. Let's 3, 2, 1. Yep, still too heavy. That's quite a bit lighter. Let's try this screwdriver. Let's try this screwdriver. The screwdriver. Let's see if this works. Oh, look how slow. That's pretty good. That's still negatively buoyant, but it's pretty close. Okay, this is heavier, but if I take some of them out, I got a little bag filled with little screwdrivers in here, so try taking some of these out. That's definitely lighter. All right, I'm gonna try the bag filled with 4 screwdrivers, little itty bitty ones like the fixing sunglasses kind of screwdriver. In 3, 2, 1. Okay, 3, 2. It's about a couple inches from the ceiling. A little too light. Let's see what else I can add in here. Oh, that's almost a little too light. Okay. Let's see what I can just drop in the bag. Finish that off. How about a pencil? I feel like this is pretty light. Got the pencil in there. Let's see. All right. Ready for liftoff? And takeoff in 3, 2, 1. Hey!
Woohoo! Yeah! That is neutral buoyancy. Stay with me for a sec. Neutral buoyancy. Not on the ground. Hovering, I can go above it, I can go below it. Neutrally buoyant. That's how much mass that can lift. Exactly. Including the balloons themselves, and including the string in this little bag, with precisely, and the carabiners. Now, these strings and these balloons don't weigh a ton, so I'm not going to worry too much about those. Let's just add a couple of grams for each of those. I'm going to take these back upstairs and get my scale and weigh this exactly.
Okay, so the next thing, of course, is I have to actually count. So let's say this many helium balloons is giving me approximately. This seemed like a good idea at the time. All right, so up to it. I'll just wait right here. That's a lot. Alright, so I've got my kitchen scale. I do have a more accurate scale out in the garage, but it's a snow day, so I don't want to walk through that. We're hoping that this is accurate enough. It should give us at least to a gram. Plus, we're kind of factoring in the actual mylar and the balloon string. We're not going to we'll just add a couple of grams here and there for those things, but not a ton. So it's going to have to be close enough, but this should give us a better accurate measurement. And I've got the thing that it did manage to suspend here. So let's combine these with the document camera and get her done. Okay, so we just have to make sure we zero this out and that it's in the correct unit measurement, which is in grams. So I'm going to take this, make sure everything is centered over top of there, nothing's touching. All right, and that gives us, let me just scoot that over. There we go. So that gives me 62 grams. All right, so it could float 62 grams plus a little bit more for the mylar and the strings. Okay, that's a lot more accurate than the spring scale method, but the spring scale method also had to float the spring scale itself plus the actual carabiner and string as well. So I think this is probably a more accurate thing. Add another maybe 5 or 10 grams on top of that, but that's pretty good. All right, so let's add it on up. And thank you very much for taking part in this. Now, here's the math. Are you ready? Okay, so we now know that it's about 65, maybe 70 grams worth of lift for all 14 of those balloons. We know the measurement on average of those balloons is about 12 by 6. So you can figure out the rough volume of the helium. And so 12 by 6 times 14 is going to give, and put it into the cylinder stuff, you're going to need to figure out how much helium that is. But let's say 14 balloons if I want to do this the fast way. 14 balloons will float about 65 grams. Awesome. That's not enough to float me. I'm really glad I didn't jump off the roof, hoping to hold... Yeah, Mary Poppins doesn't end well if you do it with physics. I'm just saying. That's one flat lady. So, essentially, how many balloons or how much helium do I need to be able to float something like me, right? And to say nothing of how to float an entire house. I think we can safely say that's a lot. That's a lot. Anyway, so do some math, proportional reasoning. You now have the basic units that you need. And I will await your answer. In the meantime, here's some bloopers. Thanks very much, everybody. I am going to give all the balloons back when I'm done. Assuming they survive. Assuming I survive. Hey! Look, Ma, no hands. That's fun. Alright, so that's also very low ceiling now. Let's give this a try. Okay, well. Let's try this. Okay, so the next thing, of course, is I have to actually count. So let's say this many helium balloons is giving me approximately. This seemed like a good idea at the time. Alright, so hop to it. I'll just wait right here. That's a lot. I bet you thought that I wasn't going to tell the answer. Yeah, no. I know, you want the answer. So if 14 balloons can lift 70 grams, then how many balloons can lift 75,000 grams? Well, you take 75,000, you divide it by 70, and you get this number here. That is your scale factor. Your scale factor is the amount that you need to multiply this number to get the other number there. So you need to do that scale factor for 14 as well. So you times 14 times that, and the answer is... you need about 15,000 balloons. We're gonna need a bigger house. See you later, everybody.